Okay, so what is CGI? It's math instruction that allows students to use their own strategies to solve problems. It was created by Tom Carpenter and a team of researchers in Michigan, I believe. Tom has since passed away, but Linda Levy continues his work. It's based on the philosophy that children already have many math skills when they come to us at school. And so by us making, say, okay, we're going to subtract two-digit numbers, and you start at the ones, and you have to start at the ones, and you have to look at the tens, we're really dampening their skills, and we're kind of, they might not see it that way. What we found out the very first day of class is that something that we think of, well, that's just a plus, that's just an addition. There's 3 different kinds of addition problems. There's 3 different kinds of subtraction problems. There's 2 different kinds of division, and then there's these other ones that have no mathematical aspect. There's 5 other problems. There's like 13 different ways to look at what we would just say, well, that was, we were supposed to add, or we're supposed to subtract. So it's student-centered instruction because the students can use their strategies, and we build on that. The teacher is more of a facilitator than an instructor. I was just talking to Sarah Villegas today. We had a meeting, our group had a meeting, and she was looking at some of my stuff, and she was asking, so what is this? And so I was telling her, really, the kids are the ones that teach each other. And to tell you the truth, I could go up and show the same strategy that one of my second graders shows. None of them would get it. Maybe one. But one of my second graders goes up and shows, and all of a sudden the next day, the whole class is using that strategy and using it very well. It's the most amazing thing I've ever seen. So how does it fit into the Iowa core? It allows students to work collaboratively. As Mike said, we do group work. They have to communicate. They have to be able to express their ideas, and they have to be able to listen to each other. And we do a lot of comparing strategies, which Carol brought this one down. So we might look and say, okay, look what Max did, and look what Brett did. How are these the same? How are they different? And if you would have heard their explanation, you probably could figure it out. It provides a deeper understanding of the number system. As Mike said, that rote memorization, or, well, I cross out this number and I take it down 1, doesn't help them really understand the numbers. It's just a system they go through. So it's kind of like if we look at those 21st century skills, and we look at how other countries and things are doing it, instead of going this way, we need to go this way and really understand what we're doing. It provides a chance for students to communicate in written and oral form about their thinking. So what outcomes can we be expected? Raise student achievement in the classroom and on the ITBS standardized test. I can attest in the classroom, I did not teach a page out of my addition unit at the beginning of the year. We did these addition problems. They're called join, change unknown, and join result unknown. And we took apart numbers. I'd give them a number. I'd say, today we're going to do 18. How many ways can you make 18? And I gave them the test out of the book when we were done. And I had 90% of my kids pass it at 80% or better. And I can guarantee that if I went back, could get back in my old grade books and look at past years where I taught traditionally, I did not have that kind of percentage. And granted, it's a different class, but still, I did not have that kind of achievement. Now, the ITBS standardized test, we may not see huge leaps and bounds this year, but the schools that we've talked to that are deeper into CGI say that they have seen raised achievement on their ITBS after, what was it, 3 years, Mike?
3 to 5 years.
The thing that I'm liking the most is that they'll have a deeper understanding of numbers. The way my kids can manipulate numbers now is amazing. This little guy right here, the other day we did 52 times 9. Now, if you would have told me 2 years ago that I was going to have second graders multiplying 52 times 9, I would have told you were absolutely nuts. But he just sat there and he went, well, 10 50s is 500, I only need 9, so that's 450. 9 times 2 is 18, so that's 468. And he did it about that fast. The instruction meets all students. I know Mrs. Reeve has one student that is a little bit lower achieving. All we have to do is change the numbers. I have a student that has an IEP, all I have to do is change the numbers. They can do the exact same problems, or if I have a kid that needs harder numbers, it's all about number choice. So here was an example of a problem we did. You see it says no one had blank turkeys. Each turkey had blank feathers. How many feathers do the turkeys have? And then we give them a number choice. And the first number choice was he had 4 turkeys. Each turkey had 11 feathers. Some students will draw out 4 turkeys. They'll make a big circle, and they'll put 11 feathers on it, and they'll count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And we call those kids direct modelers because they're doing exactly what the problem says. Some students may draw the turkeys and feathers, but instead of counting each and every one, they'll go, well, 11 is 10. There's a 10 there. So I can count 10 on each turkey, and that's 10, 20, 30, 40. But I have one more, so I go back and go 41, 42, 43, 44. Or some kids may even be able to count by 11s. I had one student that decided it was easier to count by 4s, so she drew 11 turkeys with 4 feathers. And then she did doubles. 4 plus 4 is 8. 8 plus 8 is 16. And then some students are able to see the relationship of numbers, and they use a math fact they might already know. So they know 4 times 10 is 40, and then I have one more group of 4, and that's 44. Our goal is to get all our kids more efficient with the number facts, and we're getting there. So what have we seen in our classrooms? I've seen better performance on chapter tests. I've seen greater success. I have kids that, if I taught math the traditional way, they hate math. Absolutely hate math because it'll be hard for them. And they get excited about math, and they feel confident, and they know they can do it. Deeper understanding of numbers and better mathematical thinking. When Sarah looked at how we had broke apart, I think the number was 42, and one of the kids had did 5 plus 5 plus 5 plus 5 plus 5 8 times. And so then someone else goes, well, that's really like 8 times 5. And then you have 1 plus 1. And so we even drew in the parentheses so they could see, well, this is my 40 and this is my 2. She goes, well, you're doing algebra. I said, well, yeah, we are, but we don't call it that. We have improved communication. Like I said, our 2nd and 3rd graders, our kindergartners and 1st graders too, can tell you what they're thinking. It's not just, well, I just knew it. I knew it because, or I see this relationship. The students are able to learn from each other, and they can work cooperatively. And right there, more engagement. I have 21 kids, 20 kids at math time, and all 20 are engaged for the majority of the time. And we're just getting a lot more done. And all students can be successful at math. Even kids that maybe math was a struggle. Because I taught 2nd grade and 3rd grade the last 2 years, the 2nd grade girl I had, we did math facts the old way, and she struggled. And the next year I taught, she started CGI, and to watch her blossom and see her become more efficient at her math facts because she could use these other tools was just fantastic. And see her confidence grow. And we can differentiate for all learners, like I said, the number choices or the types of problems. It's really easy, even in a class of 20-some kids, to make sure every kid gets what they need. So we've given the boys a problem. Oh, okay. Carol has
I think it's what we have to realize is we don't want to put everybody in the same box for math anymore. And just because I learned a certain way to do a problem doesn't mean that it's the best. And I think that's definitely what we want to make sure that parents and teachers and everybody that helps children with math understands. I think what you have to give them is ownership. We don't, when you work with your students at home or when we work with them, we don't say this strategy, here, let me show you a better way. Because then that makes them believe that our way is better than theirs. And it may be better for us, but it may not be better to them. And one thing we don't let them do, and I'm teasing Mr. Kraft earlier, because you can't use standard algorithms. You know, we don't let them do a problem going up and down the subtraction with regrouping. They have to write everything in number sentences, and then they have to be able to back it up with what they say. And that's kind of hard for someone. And I think what parents want to do is the very first thing when they get in 2nd and 3rd grade, they get really excited and they're like, here, I can show you this way. And they'll teach them subtraction with regrouping or addition with regrouping. And we're really hoping that to get parents not to do that anymore, because we can get kids to mimic that. But when you ask them, why did you do it that way, they really don't have a deep understanding of why. But they do it because they can mimic what you've done, and they can get it right, but they don't really have an understanding. And what we're trying to give everybody is a good understanding of the base 10 system.
And not to interrupt, but they will understand those standard algorithms.
Yes.
But
They'll learn it at the right time,
They have to
too.
kind of come about it their way.
I have students that are what I direct modelers. They still have to draw a picture every single time, and that's okay, because that's the stage that they're at. And when they are ready to move on to a different strategy, they will. Because they see other people's strategies up on the wall. If they want to think, maybe I want to try what Max did, if they feel comfortable doing it, they'll give that a try. Or like, for example, on that problem with the pilgrims, they were trying to find, it was a compare difference unknown. One of my little boys took money out of his toolbox, and he put out the money for 90 cents. And then he knew if he used that 50-cent piece that he could take away those 50 pilgrims, and then he could trade his nickel in for 5 pennies, and then he took the tool away from that, and he knew that when he had back up his money, it was 38 cents, and that was the answer. And that was what was efficient for him. And when he shared that out, the next time we do a problem like that, someone else may think that's an efficient way for them to try it now too. And what we talk to them always about being efficient and accurate. And what we're trying to get those direct modelers to move up from is that they can see that it isn't very efficient to draw out 90 Native Americans and then cross off 52 of them and then have to count it. Because usually you'll see them count to 90 about 4 times before they figure out that they really have 90 there. But they learn that themselves then and see that that isn't the best way to do it, so they try something else. But they're not afraid to try it because if they do it when they're ready to move on. Another thing is when we have them reflect on their own ideas, they may get up to share and they may not have done their problem right, but when they're up there, they see the mistakes they went and they go, oh, I could have done it this way and it would have been right. So they learn from their own mistakes, and the kids are very accepting of someone. They don't go, you're wrong, because they know that's not how we operate. You know, that we talk about, was that an efficient strategy? Is there one that we could do better? Those kinds of things. And I think that parents worry about the number facts, and I think that's a common thing. We don't kill and drill anymore. You know, we don't do a lot of the time test facts. They told us we're in year 2, Sammy and I are. Some of the teachers are in year 1 for CGI. But in year 3, they tell us when we start this summer that they will give us a math fact strategy to use, and that will also be used for interventions and to diagnose where kids are at and if we need to do some kind of intervention with them to help move them along. So we're kind of excited to learn that. The CGI grant paid for the materials. If you look inside those toolboxes, they have everything from base 10 blocks to Unifix cubes to money to flip disks to a calculator, number lines, rulers, decks of cards. We use cards for a lot of things. Instead of practicing with flashcards, they get out cards and they draw 2 cards and they have to tell their partner the answer. They can do greater than and less than with that. There's just so many things that we just, that they can use, and it's up to them, except for the calculator. We don't obviously sometimes you let them use that, but they can choose out of that box whatever they need to. Some don't use the box at all. And if you look, I left on your tables, I left you a little newsletter that Linda Levy has written the books on TGI. These are newsletters that she suggests that you send home to parents. We didn't really know about them. So I talked to Mr. Fisher, and there's 5 through the year, and so we're going to start sending those home to parents. It gives them tips on ways to work with their children, gives them things to, suggestions of things to do over the summer, and they're really, really good. If you also, I turned over 2 problems. If you look at the problem about Mike, that's the problem that we have our students. This is Max Jessen from Wall Lake. He was the 3rd grade student from Wall Lake Center. And the students you have.
This is Justin Ruppnow from Sac City.
Oh, you guys ready to share out? Okay. You want to go first, Max? And we use our technology in room. We use Elmo Lobby named ours. Elmo and Avatar, right? And we kind of get really personal about them.